So in this class we will learn about auto-oxidation. So what does auto-oxidation means? As the name suggests, auto-oxidation means oxidation which is carried out automatically. But what is basically the oxidation process? Oxidation means that the reaction with oxygen. But from where we will get the oxygen now? As the name suggests, it is as auto-oxidation, so we will get the oxygen from air. There are some compounds like turpentine. There can be turpentine, or there can be something like olefinic compounds. There can be certain metals like lead, zinc, or there can be like phosphorus. These are some of the compounds which can actually absorb oxygen from air in presence of water. Now this water is actually oxidized to H2O2, and this phenomena is basically known as auto-oxidation. Now I will go through an example. Suppose we are having lead. Now this lead will actually react with oxygen. This oxygen is actually basically coming from air, and this lead will be converted into lead oxide. Now this lead oxide is now responsible to oxidize this H2O, and now this H2O will be converted to H2O2, and this PbO2 will be reduced to PbO. Now here basically some terms are involved, that lead is actually acting as activator. Why? Because it is actually reacting with O2 or oxygen to be converted into PbO2, and this PbO2 is basically responsible to oxidize H2O. So therefore Pb or lead is acting as activator, whereas this PbO2 is known as auto-oxidator. It is known as auto-oxidator. Why it is known as auto-oxidator? Because it is automatically oxidizing H2O to H2O2. We are not providing any other chemicals, right? So it is basically forming PbO2 by reacting with oxygen, and this PbO2 is automatically oxidizing H2O to H2O2. So now this H2O is known as acceptor. Why it is known as acceptor? Because it is actually accepting the oxygen from PbO2 to be converted into H2O2. So that's why it is named as auto-oxidation. There can be other examples also, like you can have these turpentines, or we can have these olefinic compounds or unsaturated compounds, which can actually act as now activators, and they are supposed to take up oxygen molecule at the double bond position to form unstable peroxide, which is called as monoxide. I will show, or I will give you an example. For example, we are having this molecule that is RCH double bond CH single bond R. This is like olefinic double bonds. There can be several examples like turpentine. There can be olefinic double bonds. There can be unsaturated compounds also. I am giving you an example of this double bonded compound. Now this double bonded compound will react with this oxygen which is coming from air, and it can be converted into a peroxy linkage like RCH single bond CHR, and these O2 will be involved in this CH single bond CH bond. Now this is known as monoxide. This is one kind of unstable peroxide, and it is actually known as monoxide. Now this monoxide is actually responsible to oxidize this H2O to H2O2. Now this monoxide, that is RCH single bond R, this is the monoxide which will actually react with this water molecule, and this water molecule will now be converted to H2O2, and this monoxide will again be converted or will be reduced to corresponding double bonded unsaturated compound. So similarly, now here these unsaturated double bond, or you can say that olefinic double bonded compound is actually acting as the activator. Here this molecule is acting as activator. Whether it will be a turpentine, it can actually act as activator. Whether it will be a olefinic double bond, it can act as activators. So these are there can be several examples through which we can explain the auto-oxidation. But the main phenomena of auto-oxidation, that is the oxidation of H2O to H2O2, which is carried out automatically. we are not involving or we are not adding any kind of other chemicals, right? So it is actually being oxidized automatically by the oxidation of other compounds like turpentine, olefinic compounds. There can be several metals like lead, zinc, or phosphorus. Okay. Now, in one step forward, we will try to explain this concept towards a new topic. That is, the concept of this auto-oxidation can help to explain the phenomena of induced oxidation. What does this induced oxidation means? Induced oxidation means that suppose we are having a compound which is not oxidized automatically or normal condition. At normal condition, it will not be oxidized, but in presence of a particular compound, it can be oxidized, or it can be oxidized forcefully. That is known as induced oxidation. I will go through an example. Okay, so suppose we are having a solution that is Na2SO3 solution. Now this Na2SO3 solution is actually oxidized by air. So it will be oxidized by air in normal condition or normally. But if we are having a solution of Na3ASO3, it will not be oxidized by air. So this solution will not be oxidized at normal condition. But the trick is that if we are having both the solution, or if you are having a mixture of both, then it is observed that both are oxidized. This is known as induced oxidation. So basically, what is induced oxidation? Na2SO3 solution is oxidized normally by air, but Na3ASO3 solution is not oxidized by air. But if the mixture is taken, in the mixture, if both of these compounds are present, then both are oxidized. So Na3ASO3 is basically oxidized due to the presence of Na2SO3. This is known as induced oxidation. So what is basically happening? Now this Na2SO3 in presence of air, it will react with oxygen to be converted into Na2SO5. Na2SO5. It is also a monoxide. It is also a monoxide. Okay, it is also a monoxide. Okay, so now these Na2SO5 is responsible to oxidize these Na3SO3, Na3ASO3. Now Na3ASO3 cannot be oxidized in presence of air. It cannot be oxidized with the help of oxygen. But as soon as this Na2SO5 is formed, now this Na2SO5 is now responsible to oxidize this Na3ASO3. Now this Na2SO5 will try to react with Na3ASO3, and then this Na3ASO3 will be oxidized to Na3ASO4, and it will be converted to Na2SO4. Na2SO5 will be converted to Na2SO4. So these are some kind of applications of auto-oxidation. So through this auto-oxidation, we are explaining this induced oxidation. So induced oxidation is basically, I will explain through the example, that is Na2COSO3 is basically oxidized in presence of air. It is in normal condition, but Na3ASO3 cannot be oxidized in presence of air, or it cannot be oxidized at normal condition. But if you are taking the mixture of both of the compounds, then due to the formation of Na2SO5, it is actually acting as the oxidant. It will actually oxidize the Na3ASO3 to Na3ASO4. So this is known as the induced oxidation. That is, Na3ASO3 is actually oxidized in presence of Na2SO3. But if Na2SO3 is absent, so it cannot be oxidized. So this is known as the induced oxidation.